Hello guys, now here we are to understand the case of production of water from injection towards production well in case of barrier. Now started, make a new file. It is basically a two-layer case. Now let's suppose the name of the file injection well 84 and save it. Come to grid mesh size 1 and model thickness 20, layer number of layers 2, number of rows 30, and model extend up to 300 meter, number of columns 40, and a model extend up to 400 meters. Okay, as we can see here, extra area from the domain. To remove this area, option coordinate system, x1 shall be minus 20, y1 minus 20, x2 425, and y2 325. This is because we have uh, 300 number of rows and 400 number of columns. As you can see, it is fit on the page. Okay, we have to adjust or subdivide the grids for the placement of well locations. So here we can do further subdivisions. 3 column, 3 rows, copy and like this. And further, yeah, it is much better now. Yeah, it's fine. Save it, backup, yes. Now come to the grid. Second step, layer properties. As you can see here, transmissivity varies. Yes, we're going with this as it is one of the good option in our scenario. And cell status, I bound, making a boundary of hydraulic head. So we use cell 1 with -1 as it is a constant hydraulic head. So we copy it from this tab and make a boundary. This boundary is only for the first layer, so we have to copy it to another layer. Just press this tab and switch to second layer. So it is also copied to the second layer. Save it. Yes. Top layer. The layer bottom elevation has been specified. Use it for the layer top elevation. Yes. As we can see here is 0, the layer 1 elevation, and layer 2 top elevation -10. Yes. And bottom of layers -10 and -20. Yes. Now come to the parameters. First we have to set the time, switch it to days from seconds. Steady state flow simulation. Yes, okay. Initial and prescribed hydraulic head. Uh, Reset matrix -2, and it applies only to the first layer, so we cannot select this tab apply to the entire model. No, okay. Save it. Come to the next parameter, horizontal hydraulic conductivity. Yes, and reset matrix and apply it 1 as it is applied to entire model. Okay, save it. Now, sorry, initial and prescribed hydraulic head, we should change it to minus. Okay, it's correct. Now, the horizontal conductivity, check the values 1 and apply to entire model. Yes, okay. Yes, parameter vertical hydraulic conductivity, we can assume it zero point 0.1. Okay, apply to entire model so that layer first is 1 and also the layer 2, which is we can see it here 1. Yes, save it. Now come to the effective porosity. Reset the values and we can assume that our effective porosity is zero point 0.1 and apply to the entire model. Save it, yes. Bulk density, okay. Now come to the well locations. Yes, here we can plot our injection wells and production wells from one or second layer. For first layer, we are selecting our injection wells. We are injecting 25 cubic meter of a fluid, and for the second, you may copy from it here and place, but we are selecting individually. Okay, and this is 25. Yes. Come to the second layer. We are placing our production well here, and because of production, we introduce negative sign minus 50. Okay, we are going to save it. Yes. Before executing our model, we have to select following a recharge and horizontal flow barrier. For the recharge reset matrix, let us assume it our recharge. Select the recharge is applied to the highest active cells. Okay, yes. Save it. Yes. And models flow barrier for the horizontal flow barrier to avoid the cortical movement from the injection well towards production well. So we assume an example here. So just select any location where you going to provide a barrier. So hydraulic conductivity or thickness of the barrier. Hydraulic conductivity divided by thickness. So assume it 0.00082 and barrier direction. So initially we are considering it 1. So copy it and make a barrier. So now change the direction. Okay, yes. Now we have to copy this barrier to the second layer. So just press that tab, switch layer and go to the, so it is copied to the second layer. Save it. Yes. Now we're going to run our model. Check model data, regenerate all input files. Okay. Yes. Now we're going to PM path for the particle movements. Now let's zoom in and 30 radius 1.5 meter and 3 meter. Okay. Now the another layer, oh sorry, another injection well. It is okay. Now switch to the second layer and zoom out. So make here also, which is our production well. Okay. Now particle tracking. Step length 30 days, which is 1 month, and number of steps 12. Change the color, make it blue, and this one red. Okay. Use the following table, ignore the particle colors. Okay. Now environment uh, 14 and 14. Here you can see the row and columns of the well. So it is 14, 14. So environment cross section. Say 14, column 14, exaggerate model up to 5 times, and it is good now. So you can see here cross section, and here is the our wells and a barrier of some impervious material, might be bentonite or anything which is impermeable. Here is our two injection wells, and one is of our production well. So we are now running our model. See that the particles from this injection well and this injection well cannot move from the barrier and won't allow particles to move directly towards the injection well, production well, sorry. So if we restart it and step by step, 1 month, 2 month, 3 month, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now restart, make it another move, make it another. Now here you can see the cross section, and here is the, it is very important, and it is very easy to understand how your barrier work against the injection and production well, and what is the effect of the barrier accordingly. So, okay, thank you.